Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. Yes, my dear students, today we are going to start with lecture number 3rd based on the chapter P block elements under our batch Excellence batch. I hope so, students, you have seen the previous lecture and all the topics were clear to you. So, let us proceed to today's session. But before that, let me ask you a simple question. What it takes to succeed? My question is, what it takes to succeed? So listen very carefully to the answer. See, basically, the road to success is not straight. The road to success is not straight. There is a curve called failure. There is a loop called confusion. Speed bumps called friends. Now, I'm not referring to all the friends, but the few ones are the speed bumps that are friends. The red light called the enemies. The caution light called the family. So, what does family do? They basically support us, they guide us where we are wrong and where we are right. So, the caution light are family. But if you have a spare called determination, an engine called hard work, insurance called faith, and the most important, a driver called God. So you will make it to a place called success. Yes, my shimmering stars. So with this quote, let us start our today's session. So as you all know that our batch name itself is Excellence Batch. So we have to, be very confident in what we do. And we have to keep working hard in order to excel in our field. Yes? So let us start our today's session. As you all know, this is lecture number 3rd. So let us see what are the topics we are going to cover in today's lecture. So topics to be covered. So as you all remember that in the previous lecture, we have studied with regard to the nitrogen family. Yes, we were studying the compounds related to nitrogen family, and we studied about, ammonia, its method of preparation, its physical properties, its chemical properties. Yes. So now in today's session, we are going to start with the last compound with respect to the nitrogen family. That is going to be nitric acid. And after that, students, we shall be proceeding towards the phosphorus. That means we are going to study with regard to phosphorus. What are the allotropes of phosphorus? Okay, then we are going to study about phosphine, and then further we shall proceed towards our group 16 elements. That means the oxygen family. So the very first segment that we are going to start with today is going to be nitric acid. Okay, then we are going to study about the allotropes of phosphorus. And then we shall study about phosphine. And at last, we shall start with the group number 16, that is oxygen family. So basically, we are going to end with the group number 15, that is nitrogen family in this session, and we are going to proceed further to the group number 16. So as per the very first topic, that is nitric acid, first of all, we should know what is nitric acid. Nitric acid is basically HNO3. Yes? Okay. Now students, what are the methods of preparation? See, as you were studying in the previous lecture also, what we did? We basically studied first of all the preparation method. And then we further proceeded towards the physical properties. And after that we have moved on to the chemical properties. So this is going to be the procedure for all the compounds, whether it is of nitrogen family or the phosphorus, or we are talking about oxygen family and so on. So when I'm talking about nitric acid, first of all, I shall be studying about the preparation, then the physical, then the chemical properties. Is it clear? So if I talk about the preparation method, so basically we are going to prepare nitric acid with the help of two methods. One is going to be the laboratory method, another one is going to be the industrial method. So when I'm talking about the laboratory method and the industrial method, both are very important with regard to the nitric acid. Because when I'm talking about the industrial method over here, we shall be studying about the Ostwald process. So basically it will come by its name itself. As you all know, in the preparation of ammonia, we were talking about the Born-Haber process. So that came with its name itself. And similarly, in the case of nitric acid, Ostwald process is generally asked. Okay. okay, directly. So you have to study it very carefully. So first of all, if I am saying that we have to see the methods of preparation, so we shall discuss about the laboratory method first of all. So what are the methods of preparation? Now the very first one, as I told you, it is going to be in lab. That is the laboratory method. So when I'm talking about in lab, how to prepare HNO3, for that we need to react NaNO2 with H2SO4. We need to react NaNO2 with H2SO4. And on reaction, what we shall obtain? We shall obtain HNO3. And what will be the byproduct that shall be obtained from here? That will be Na2SO4. It is a very simple reaction. Right, my dear students? Now again, I would recommend you, if you want to open your NCERTs, yes you can, but students, let me tell you one thing. If you're not writing a certain reaction, that means you're not learning it out or you're not practicing it out. In order to learn something, in order to revise something, you need to write it down. Just by looking at it or just by listening to it, you won't be able to learn it. Okay? So please do that. Now, if I'm talking about in laboratory, it is very simple. When you are reacting NaNO2 with H2SO4, you shall be obtaining your HNO3, that is your nitric acid, and Na2SO4 is the byproduct that is obtained over here. Now, the most important thing that we need to know over here is about the industrial method. So in industrial method, students, I am talking about by Ostwald process. By which process? By Ostwald process. Now this certain process occurs majorly in 3 steps. Do remember this? It will occur in majorly 3 steps. If I talk about the very first, the initial step, I would require ammonia. Now, if I react ammonia with oxygen, in the presence of platinum or the rhodium and the gauge catalyst, I shall be obtaining what? I shall be obtaining NO, that is nitric oxide. Now, that means I have to produce, in order to produce nitric acid, I shall be doing the major 3 steps. So, what is the very first step over here? If I talk about the step number first, what I require ammonia, and I will react ammonia with oxygen. And this reaction will occur in the presence of a gauge catalyst. Also, platinum and rhodium is used over here. Now, students, you can also remember the temperature as well as the pressure that is being provided over here. The temperature that we use over here is 500 Kelvin, and the pressure, if you want to write, it is 9 bar. Okay? Because this is important, so it will be better if you learn it out. Now what will happen? When ammonia reacts with O2, it produces what? It produces a nitric oxide, that is NO. It will produce NO. First of all, NO will be produced, and if you want to balance this equation out, you shall be seeing that water is also produced as a byproduct over here. Now in the very next reaction, in the very next step, what shall happen? This NO will further react. This NO will further react with O2 in order to form NO2. Now what will happen in step number 2? What will happen in step number 2? Let us see. In step number 2, this NO will again react with O2 in order to form NO2. In order to form NO2, that is nitrogen dioxide. Is it clear to you? In order to form nitrogen dioxide. If you need to write over here, you can write over here, it is nitric acid. Oh, oxide. Very sorry. Now what will happen in the further third step? In third step, this NO2 that is being produced over here further reacts with water and it produces nitric acid. Along with nitric acid, again NO is released over here. So what is the third step? Let me write the third step over here. Okay, kindly write the third step. I am writing it over here. What is the next third initial step? What will happen? This NO2 on further reaction with water produces HNO3. Also, NO is produced over here. Is it clear to you? Now, students, what happens? When you are obtaining nitric acid from here, you will further react it with concentrated H2SO4. And what will concentrated H2SO4 do? It will basically remove the water from this. Okay, from the HNO3 that is being obtained over here, it will let us to obtain a very pure amount of nitric acid by removing the amount of water that is present over there. So you can further react it with H2SO4. So basically, how we have to prepare this HNO3, these are the major 3 steps which I have told you over here. The very first initial step is you have to react ammonia with O2 in order to form NO, that is nitric oxide, and then this nitric oxide with further reaction with oxygen will produce you nitrogen dioxide, which on further reaction with water will let you obtain your nitric acid as well as NO is obtained over here. Is it clear to you, students? So this is the method of preparation with regard to, if I say HNO3, that is your nitric acid. Is it clear to you, students? Is it clear to you? Now kindly write it down so that we can move on to our next part. Now students, we shall see the physical properties with respect to the nitric acid. Now if I talk about the physical properties, you should know that in the pure form, it is a colorless liquid. Now this colorless liquid that is written over here, it is present in the pure form. But what happens, sometimes you shall be seeing that there is an impure acid also. Now impure acid is basically yellow in color. When you are seeing the nitric acid and its color changes to yellow, then that means there is some impurity that is present over there. Now what is the impurity that shall be present over there that makes it a yellowish color? That is NO2. That means if nitrogen dioxide is present in HNO3, it will make it impure. Are you getting my point? In the pure form, it is colorless liquid, but when there is an impurity such as nitrogen dioxide present over, in HNO3, it will make it in a yellow color. That will become an impure acid because there is a certain kind of impurity. So you can mention it over here. The very first physical property is, yes, it is a colorless liquid. No doubt it is a color liquid, but impure acid is yellow. Impure acid is yellow due to presence of impurity such as NO2. Is it clear to you, students? Now, if I move on to the further, the next characteristics that they have told you over here, that laboratory grade nitric oxide contains 68% of the HNO3 by mass and has a specific gravity. There is no need to learn all of these, students. Other than this physical property that you should know, it is corrosive in nature. Okay, and one more thing. Just tell me how many H positive ions does HNO3 can liberate. Basically, what is the structure of HNO3? If I ask you, it shall look like this. Now, this is the structure for HNO3. Okay, so if I ask you how many H positive ions can be liberated over here, you will be saying that, ma'am, only this H positive ion will be liberated from here. That means only one H positive ion is released from here, and that's why it is referred to as a monobasic acid, because it can only liberate one H positive ion. So basically this is the structure. If you want to write down, this is the structure for HNO3. This is the structure that I have drawn over here for HNO3. Now, these are the simple physical properties that you need to remember over here. I guess this is clear to you, students. Now, students, come the chemical properties. Now, we shall study about the chemical properties. Now we shall study about the chemical properties. See, if I talk about what are the chemical properties with respect to HNO3, so the very first chemical property is that they are acidic in nature. The very first is that they are acidic in nature. Okay, if they are acidic in nature, now let us do a simple, a certain kind of a reaction. For example, HNO3, it reacts with water. So what shall it produce? What shall it produce? As it is acidic in nature, so you shall be obtaining two kinds of ions over here. One is H3O positive that is being produced over here. Another one is NO3 negative aqueous. Right? So this is the initial reaction when it states that they are acidic in nature. Now what is the next chemical properties that you can do? It's the reactions are certain. When I talk about the chemical properties, that means we are looking upon to the chemical reactions. So HNO3 further can react with metals and they can produce certain gases. I will let you know which gas is being produced. So first of all, write this chemical property so that I can move on to the next slide. Also draw this structure over here, students. Okay, students, now talking about the next chemical property is action on metals. So when I talk about action on metals, do remember one thing. First of all, chromium and aluminium do not react with HNO3 because they form a certain kind of oxide layer. A passive film of oxide layer is formed on its surface. Hence, they do not react with HNO3. Which one? Chromium and aluminium. Do remember this thing. This is the very first initial step. Other than this, if I talk about the action on metals, so what we shall obtain? Now see, if I do reaction of zinc with HNO3, now over here, why I have written 2 times? Because once I am taking HNO3 as concentrated, and in the another form I shall be taking as a dilute HNO3. Okay. Similarly, what I will be doing? Cu on reaction with HNO3. Again, I am taking concentrated HNO3 over here, and over here I am taking it as dilute HNO3. Now see, it is very important. Kindly put a star mark over here because it is very, very, very important, my dear students. Now, what shall you obtain over here? First of all, ZnNO3 twice. Similarly, here, this is the initial product that you shall be obtaining. This is the initial product I am talking about. But you have to focus on the further products that is being obtained. CuNO3. Here CuNO3 twice. So this is the initial product that we form over here. But what you need to remember is, whenever you are talking about the concentrated HNO3, either you are reacting it with zinc or you are reacting with copper. Do remember, whenever you are reacting with concentrated HNO3, you shall be obtaining with it NO2. You shall obtain NO2 over here. Do remember this thing, that NO2 is being obtained. Also, water is being released. Okay, now the twist comes over here. For concentrated, okay ma'am, you have told that these are the simple reactions, but what happens when you are using the dilute one? See, when you are using the dilute HNO3 and you are reacting it with zinc, what you shall be obtaining from here? You shall be obtaining N2O over here. Also with this, water shall be obtained. Now here, what is being produced? N2O. Is it clear? And when you are reacting Cu with HNO3 in the dilute form, you shall be obtaining NO, students. Let me write it with another color because that will help you to differentiate between both of them. Is it clear to you? Is it clear to you? So this is the basic difference that you need to remember. Over here, NO2 and NO2 is produced when you're using the concentrated forms. But when you're using the dilute forms with respect to zinc, what you shall be obtaining? You shall be obtaining N2O, and with Cu you shall be obtaining NO. Clear? Is it clear? Kindly write it down and put a very huge star on your NCERT. Open your NCERT and put a star mark over there. Is it clear to you all? Okay, now one more thing, they certainly ask you about aquaresia. Now what is aquaresia basically? Aquaresia is concentrated HNO3 plus concentrated HCl. Now you take it in the form of a ratio, 1:3. This is certainly asked, and it is basically referred to as a royal water. Okay, so basically it is referred to as what? Royal water. So this is also certain thing that you can see in your NCERT being asked. You can write it over here for your knowledge sake. What is aquaresia? It is concentrated HNO3 plus concentrated HCl taken in 1:3 form. Is it clear to you? Is it clear to you? Okay, shall we proceed further, students? I hope so. This chemical property is clear to everyone, right? Now, students, the next chemical property that we will be learning over here is about oxidation of non-metals. This was action on metals. The next chemical property is oxidation of non-metals. Oxidation of non-metals. This is the next chemical property that we study over here. Now, whenever I talk about the oxidation of non-metals, do remember this, it is very simple. Either you are reacting with, let us say you are reacting with I2, you are reacting it with, let us take carbon. Other than this, you are taking sulfur also, and you know, phosphorus, it exists in the form of P4. Sulfur exists in the form of S8. Okay. So we have to react it with HNO3. HNO3. We have to react it with HNO3. We have to react it with HNO3. We have to react with HNO3. Yes, my dear students. Now see what you will be obtaining from here. See, in each of these reactions, you shall be obtaining NO2 and water. This is the very first initial thing that you should know. Over here, NO2 plus water is being formed. 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 Now, what is the major product being formed over here? These are the, byproducts. What is the main product that is obtained when you get it reacted? So, when I2 gets reacted with HNO3, it produces HiO3. It produces HiO3. Do write it down first of all. Is that clear? Now, when carbon reacts with HNO3, it produces CO2. It produces what? CO2. When basically sulfur acid reacts over here, what happens? H2SO4 is produced. Is it clear to you? These are very simple reactions. And when P4 reacts, what do we get? H3PO4. Kindly write this reaction so that we can move on to the further next topic. Kindly write it down, students. This is the oxidation of non-metals. This is with respect to oxidation of non-metals. Is it clear? Is it clear to you all? Okay. Now, students, these were chemical properties. But other than this, there is one more topic that we need to understand. That is the brown ring test. Now, what is basically brown ring test? See, basically brown ring test, we are talking about nitrate ions over here. Now, what are nitrate ions? See, from nitric acid, we shall obtain nitrate ions. Now, what are nitrate ions? What happened to this? Okay, so very sorry. What are nitrate ions? It is NO3 negative ions. So here we will be seeing the detection of NO3 negative ions in the brown ring test. Now, how is brown ring test performed? Let me tell you. First of all, we shall be having a solution that contains NO3 negative ions. Now, if we need to identify it, initially we are assuming that there is a solution which contains this, because we know we have to find out whether it has that ions or not. So we will be first of all having a solution having NO3 negative ions, that is the nitrate ions. Now, what happens over here? Now you will add, what you will add over here? You will add the freshly prepared FeSO4 solution over here. Now, what to happen after this, students? You will be adding concentrated H2SO4 from the side. You have taken a beaker, and in that beaker you have that solution, and first of all you have added FeSO4 solution. Now you will take a very you will take something like, you have to take in a very small amount concentrated H2SO4, and you shall be pouring from the end of the beaker. Okay, so what will happen when you will be pouring the H2SO4 concentrated solution into this beaker which has FeSO4 solution itself in it? What will happen? A brown ring will be obtained over here. So after this, you shall be inserting H2SO4 over there, and then you will be seeing the brown ring that is being formed over there. Now, let me tell you the complete procedure for this. See over here, these are the lines from NCERT. Familiar brown ring test for nitrates. Now, what are nitrates? I've already told you. It is NO3 negative. Depends upon the ability of Fe plus 2 reduce nitrates to nitric oxide, which reacts with Fe plus 2 to form a brown colored complex. Now, here they have shown you the initial procedure for the certain test. The test is usually carried out by adding dilute ferrous sulfate solution, which I've already told you, freshly prepared, to an aqueous solution containing nitrate ions. So we will be taking the solution and we shall be adding over there FeSO4 solution, and then carefully adding concentrated H2SO4, that is sulfuric acid, along the sides of the test tube. So when you are adding it down, what shall happen over here? A brown ring at the interface between the solution and the sulfuric acid will be obtained. Now this layer indicates the presence of nitrate ion in the solution. This is really very important. Now if they ask you what is the formula for the brown ring, okay, so you should know this thing also. It is Fe. Now basically it is a kind of a complex being formed, so we use a square bracket over here. Then comes water. Now here when you are taking the molecules of water, there are 5, and then one is NO, and the charge that balances it out is +2 over here. Is it clear to you? So this is the formula for the brown ring. And this is a procedure which I've already told you. So you can mark in your NCRTs the key most important lines over here with respect to the brown ring test. Is it clear to you, students? Now we shall move further to the next topic of ours, that is, before moving on to the next topic, there are some uses with respect to the nitric acid. Let us read that. The major use of nitric acid is the manufacture of ammonium nitrate for fertilizers and other nitrates for the use in explosives and the pyrotechnics. It is also used for the preparation of nitroglycerine. This is very important. It is used for this preparation, trinitrotoluene, as well as other organic nitro compounds. Other major uses are they are used in the pickling of stainless steel, etching of the metals, and as an oxidizer in the rocket fuels. Is it clear? So these are the uses that you need to just read out from your NCRT. That's it. Okay, students. Now this ends our nitrogen segment over here. One more thing. Yes, okay. So there are some oxides of nitrogen and the oxo acids of phosphorus that we shall be studying all together. Okay, that we will be doing at the end of the session. Okay, so the next topic we shall start now will be the phosphorus and its allotropic forms. Let us start with the phosphorus and its allotropic forms. Now, first of all, what is the question that arises in every student's mind, in each student's mind, sorry. What are allotropes basically? Allotropes are the different physical forms of the same element having different physical properties. What I am saying, different physical forms, different physical forms, different physical forms of same element having different physical properties, having different physical properties. Now basically it is a same element present in different forms with different physical properties. Now when I talk about phosphorus, they have three allotropic forms, very important. If I talk about phosphorus, it has three allotropic forms, very important. The very first is the white form, the white phosphorus. The very first is white phosphorus. The second one is, students, red phosphorus. The second one is red phosphorus. And the third one is black phosphorus. The third one is black phosphorus. Now, students, if I talk about the very first one, if I talk about the white phosphorus, in order to talk about white phosphorus, see, we shall be studying its preparation methods, its physical properties, no doubt. But let me tell you one thing. When I talk about the black phosphorus, it is further divided into two major segments. That is the alpha black and the beta black. Okay. We don't have to study in depth, but yes, in methods of preparation, they are certainly asked. So if I talk about very first one, the white phosphorus, how shall it, basically it is a kind of a discrete like structure. If I draw its structure, it is somewhat like this. So this is the structure for the white phosphorus basically. Okay, and it is a discrete tetrahedral unit. Okay, also one more thing, it is the most important thing. If I talk about the white phosphorus, students, it is highly reactive. It is highly reactive, and you should know one thing, students, the one which is highly reactive is least stable. The one which is highly reactive is least stable. So these are certain kind of questions that they generally ask you over here. First of all, they are highly reactive. Second one, they are least stable. Also, they are found in the discrete form. Now, this is the discrete tetrahedral unit. Okay, it is white phosphorus, which is P4. Okay, and it is discrete tetrahedral unit. Discrete tetrahedral unit. Is it clear to you? Kindly write this first of all. Also, if you want to know the angle over here, it is about 60 degree, and there is an angle strain over here. Strain is being caused over here. Is it clear to you? Now, when I talk about the red phosphorus, what is the difference between white phosphorus and red phosphorus in the structure? If I talk about, this is found in the discrete form, but if I talk about, the red phosphorus, it is present in a polymeric chain form. It is present in polymeric chain form. Now, how does it look like in a polymeric chain form? Let me tell you. Students, so this is the polymeric chain form that is being obtained over here, that is being observed over here. One thing, let me correct it. One second. One second, I am making it again. Okay. Yes. So this is the very first unit of this. Now this comes the second unit like this. Yes. Now comes the third one and it goes on like this. Okay. So basically they are present in a polymeric chain form while they are present in the discrete tetrahedral form. Is it clear to you? Kindly write this. Now we shall write the major difference with respect to the red phosphorus and we will see the methods of preparation for all of them. Now when I talk about the red phosphorus, see basically red phosphorus in comparison to the white phosphorus are less reactive. Now I told you they are the most reactive ones, the white one, and they are less reactive. Now if they are less reactive, then they are more stable. They are more stable with respect to the white phosphorus. With respect to white phosphorus, right? Now if I compare both of them, it is non-poisonous, but the white one was poisonous. If you want to write it over here, you can write it is poisonous, but if I talk about this one, it is non-poisonous. Okay, it is non-poisonous in nature. Other than this, students, if I talk about its solubility, so it is basically insoluble in water as well as in CS2. Okay, that is carbon disulfide. But if I talk about the another one, it is the different scenario. Here I am saying that it is insoluble in both water as well as CS2. But if I talk about, white phosphorus, it is insoluble in water but is soluble in CS2, that is carbon disulfide. Other than this, I have told you they are more stable with respect to white phosphorus. This question is generally asked students, so kindly focus on this thing. Right? Is it clear to you? One more thing. When you are talking about white phosphorus and the red phosphorus, white phosphorus basically glows in dark, while red phosphorus does not glow in dark. This is also one more important point. It does not glow in dark. But if I talk about the white one, yes, it glows in dark. It glows in dark. Is it clear to you? I guess now this is the major difference that you shall learn from both of these. Now students, if I talk about its methods of preparation, before moving on to that, I want you all to write it down first of all. Kindly write it down, my dear students, so that we can move on to the next part of ours. Okay. Now third category comes out to be black phosphorus. First of all, understand this. When you are heating white phosphorus, understand this. When you are heating white phosphorus, the white phosphorus can be heated on two different temperatures and you shall obtain two different products. If you are heating white phosphorus at 473 Kelvin, if you are heating it at 473 Kelvin, what you shall be obtaining? You shall be obtaining black phosphorus, but which form? Beta form. So over here, beta form of black phosphorus is being obtained. And when you are heating white phosphorus at 573 Kelvin, now here you are using 473, but here you are using 573 Kelvin. Now what you shall be obtaining? You shall be obtaining red phosphorus. Wow, ma'am. Wow, ma'am. Okay, ma'am. This we have got to know, but how we will obtain alpha form of black phosphorus? I'll tell you. See, this is when you are heating white phosphorus. In order to, if you are talking about red phosphorus, when you heat red phosphorus, now it also has a particular temperature of 803 Kelvin. When you heat red phosphorus, you obtain alpha form of black phosphorus. Only this question is certainly asked with regard to, the alpha form and the beta form of the black phosphorus. Or I can say about the preparation of red phosphorus. How can red phosphorus be obtained? It can be obtained directly from the white phosphorus. That's it. Is it clear to you, students? Kindly write it down. So students, this ends our allotropic forms of phosphorus. Now comes our next segment, that is about phosphine. If I talk about phosphine, see, it is quite similar with ammonia, like we have did in like we did in ammonia, NH3. Similarly, what is phosphine? Phosphine is pH3. Phosphine is pH3. Now when I'm talking about phosphine, first of all we shall see the preparation method, and very easy preparation method, simple reactions are there. You know, many students I have seen, they are asking that, ma'am, there are so many reactions, how shall we learn them? So the best way in order to learn the certain reaction is to write them and understand them, that how it has been occurring. That's it. So whenever you clear your concepts and you re-revise it again and again, it automatically fits over here. But if you're not revising a certain reaction, only you are listening to it a single time, students, then there is no use of listening to the lectures also. You have to revise in order to, apply it in the questions, or in order to make your mind sharp. If you want that the reaction should remain till your examination in your mind, then you have to revise it out. Without revision, students, you can't do anything. Trust me. If you have not started revision, I'm not talking only about chemistry, about any other subjects. If you have not started revising that topic which I've already studied, you are lacking behind. If you are thinking the topic was easy, there is no need to revise. No, my dear students, you need to revise the topic. It is very, very important. Okay, because the revision will make the topic more stronger than before, so do that. Okay, now when I'm talking about phosphine, coming back to the topic, how it is prepared? Calcium phosphide, basically it reacts with water in order to form our phosphine. You can either react it with water, you can either react it with HCl. Now what I'm using over here, I'm using calcium phosphide. Now that, what is calcium phosphide? It is Ca3P2. Now what is phosphide? See, what is phosphide if you don't know this? Phosphide basically is P raised to the power minus 3 charge. And what is the charge on calcium? It is +2. So how you shall obtain calcium phosphide? See, its charge will go in its base and this charge will go in its base. So what we will get? Calcium has a base of 3 and phosphorus has a base of 2. So this is Ca3P2. How this is obtained? By this way. Now if I react Ca3P2 either with water or with HCl, I shall be obtaining phosphine with me. See, only the byproducts will change, that's it. So what will happen? If I react this with water, first of all, what I shall be obtaining? Yes, I shall be obtaining pH3, which is phosphine, no doubt. But along with this, what shall I be obtaining? CaOH twice. Am I right? Am I right? Now, if I have to react it with, if I react Ca3P2 with HCl, what shall happen over here? Again, phosphine, pH3 is obtained, no doubt. Yes, ma'am, it is obtained. But what is the byproduct? What is the another product that is obtained from here? It is CaCl2. Now students, you can balance all these equations which I am writing over here. Is it clear to you? Now this was the simplest method in order to obtain pH3. You can also obtain phosphine in laboratory method. How you can obtain phosphine in laboratory method? Now this is a kind of a different reaction. You can obtain phosphine with the help of white phosphorus. When you heat white phosphorus with concentrated NaOH. Now in laboratory, if you are using white phosphorus, I'm writing white direct reaction over here, and over here I'm mentioning it is white phosphorus. If you are using white phosphorus and you are reacting it with NaOH, you are heating it with NaOH, okay, also with water. So what you shall obtain over here? Phosphine is being obtained over here, pH3 is being obtained over here. Along with it, what you shall obtain over here? It is NaH2PO2, NaH2PO2. Okay, so this is the important reaction which is generally asked in the examination. So I want you all to put a star mark over here in this certain reaction. Is it clear to you? Kindly put a star mark over here. One more thing I want you all to tell over here, that if I talk about phosphine in the purest form, phosphine basically is the non-inflammable gas. That means which will not catch fire easily, but it will become inflammable when we can say that some kind of impurities, or I would say, for example, P4 is present over there, white phosphorus is present over there, or I would say P2H4 is present over there. So that makes it what? It makes it impure, and due to that it becomes inflammable. So if you will see the purest form of phosphine, that is non-inflammable, right? That means it will not catch fire easily. And if you need to purify that, you will certainly react the pH3 with HI. What I'm saying is, I will let you know. First of all, I guess you all have written this thing. Okay. So what I am saying is that phosphine is phosphine in pure form is non-inflammable. Sorry, N will come over here. Okay, but in impure form, it is flammable. Inflammable. It is non-inflammable, but in impure form, it is inflammable. That means it will catch fire. In order to purify, what will happen? We will react phosphine with HI. What we shall obtain over here? We shall obtain pH4I negative. This is what we will obtain over here. And after that, students, when pH4 positive, I negative is obtained, we shall further react with it KOH. And on reaction, we will obtain the pure form of phosphine. This was the impure form, which has some impurities. On reaction with HI, it formed pH4 positive, I negative, which on further reaction with KOH gives us the purest form of phosphine. Okay, along with this, if you want to balance it out, Ki is released and water is being released. Kindly write this reaction. This is also certainly asked in your examination. Write it down, my dear students. Okay, other than this, there are some physical properties with respect to phosphine, such as it is colorless. Okay, and it has a rotten fish-like smell. If you want to write, you can write it is colorless. It has a rotten fish-like smell. Okay, other than this, students, you can say they're highly poisonous. It is explosive when it come in contacts. Okay, so it is, I said it is poisonous, you can mention it. Highly poisonous and explosive when it comes in contact with either HNO3, Cl2, Br2, all the oxidizing agent. So it becomes explosive in nature. Is it clear to you, students? Kindly write it down so that we can move on to our next part. One more thing, just as we did in ammonia, we are telling you that it is kindly weakly basic. It is weakly basic in nature. Now when I'm saying it is weakly basic in nature, that means if I react phosphine with HBr, what I shall obtain from here? Now this is very simple reaction. It is PH4Br that is being obtained. Okay, so these are the certain reaction that you have to do in the chemical properties. Now if I talk about the uses of this, you can read from the NCERT, students. Uses of this is your homework. Uses of phosphine is kept as your homework that you have to read from NCERT. Now if I talk about the phosphorus, see, for phosphorus we have seen the allotropic forms of phosphorus, we have seen the topic phosphine. Now comes the last topic, that is phosphorus trihalides and phosphorus pentahalides, that we have to study. This ends our nitrogen family and then we shall proceed towards the oxygen family. Is it clear to you all? Now okay, so now moving on to the next part. The first of all we shall study about, the topic is phosphorus halides. Phosphorus halides. Now the very first that we have to study over here is, in with regard to phosphorus halide, we will be saying two kinds, that is PX3 as well as PX5. Now I want you all to open up your NCRTs and just write mark, underline over there, because you have to read from there and it is very important. First of all comes the phosphorus trihalides. And in that also, students, we shall study about phosphorus trichloride. When I'm taking X as Cl over here, it becomes phosphorus trichloride. That means it is PCl3. First of all, we shall study about PCl3. How is PCl3 obtained? Very simplest reaction. Very simplest reaction. If I talk about the preparation for phosphorus trichloride, that is PCl3. So we need white phosphorus and we will react. Now see the major difference, first of all I will tell you, then you can see from the NCERT also, and you can write over here also. If you react white phosphorus with a limited amount of chlorine, you shall obtain PCl3. But if you are using white phosphorus and you are using a very huge amount of Cl2, excess amount of Cl2, you will be obtaining PCl5. Is it clear? Very simple reaction. You are using white phosphorus, no doubt. But if you are using limited amount of Cl2, you will be obtaining PCl3. If you are using excess amount of Cl2, you are obtaining PCl5. As simple as it is. So what we have to write over here? We will be using P4, that is white phosphorus. That is white phosphorus. Now we will react it with Cl2. You have to write it is present in limited amount, in less amount, in limited amount. So what you will obtain over here? You will obtain PCl3. Very simple reaction, ma'am. It is very simple. Very simple. Also remember here dry chlorine is used. Here dry chlorine is used. One more reaction. In comparison, there are only two methods of preparation. And yes, students, they do mistake over here. What will happen? I will be using now thionyl chloride over here. I will be using thionyl chloride, and do observe when I will be using the method of preparation for PCl5, I shall not be using thionyl chloride over there. There is a very small difference that you will be observing. See, this is the very first method of preparation. Now in the next method of preparation, I told you, I am taking white phosphorus again. I am taking white phosphorus over here again. And now I am reacting it with SOCl2. That is thionyl chloride, ma'am. That is thionyl chloride, and on reaction we shall obtain PCl3. Very simple. We will obtain PCl3. Other than this, SO2 is obtained. What happened? Okay. Other than this, SO2 is obtained. Other than S2Cl2 is obtained. There is no need to, remember the byproducts. But yes, if you will do so, it will be helping you only. Is it clear to you? Is it clear to you? This was the preparation method with respect to phosphorus trichloride. Now, students, if I talk about its properties, so basically they are colorless. They are oily in nature. They are liquid. They are colorless. And yes, there are certain reactions that you need to remember over here, such as the hydrolysis reaction. Okay, let me take one more sheet. Kindly write it till then. So I told you they are colorless, oily liquid. They are colorless, oily liquid. Yes, other than the students, if I talk about the chemical properties, I told you about the hydrolysis reaction. Now, what happened in the hydrolysis reaction? Basically, we are taking now what? We are taking PCl3, right? What will happen? See, PCl3 on reaction with water, what it shall give us? This is the important thing. It will give us H3PO3. This is certainly asked in your examination. Also, HCl is being released over here. This is very important reaction. Okay, is it clear to you? Now, few reactions are also there which is very easy, such as if I take CH3COOH over here and if I react it with PCl3, very simple. Just replace this OH with chlorine. What you shall obtain? You will obtain CH3COCl. Is it clear to you? Also, H3PO3 will be released. Now, one more reaction. If I say over here C2H5OH and I am reacting it with PCl3, again, you have to replace OH with Cl. You will obtain C2H5Cl plus H3PO3. Is it clear to you? This is the very simplest reactions that you need to remember with regard to the PCl3. Is it clear to you? Now comes, students, the next one, that is the PCl5. Now comes the last with regard to phosphorus, that is PCl5. Phosphorus pentachloride. Now when I talk about phosphorus pentachloride, again method of preparation is very easy. You will be taking white phosphorus, and now what you will be doing? Very simplest reaction. When you have taken white phosphorus, over here you will take excess of Cl2. When you are taking excess of Cl2, you will obtain PCl5. When you are taking the limited amount, you shall be obtaining PCl3. Is it clear to you? Now in the previous case, in the next method of preparation, I took thionyl chloride. But over here, I will not be using thionyl chloride. I will be taking sulfuryl chloride. Okay, that means here I am taking again white phosphorus, no doubt. But here I am taking SO2Cl2. In the previous case, I took SOCl2. Do remember, this is a very silly mistake that students do over here. And you shall be obtaining PCl5. Also, SO2 gas is being released. Is it clear? So, this is the very simplest method of preparation if I talk about with regard to PCl3 and PCl5. Great. Now, when I'm talking about the properties, that was colorless, but it is yellowish. It is yellowish white powder. It is yellowish white powder. Is it clear to you? Now, again, there are certain reactions as we did in the previous case. Similarly, hydrolysis reaction we'll do over here. When PCl5 students react with water, what shall it produce? In the previous case, it produces H3PO3. But over here, it will produce POCl3. It will produce POCl3 with HCl. Now, it is a two-step reaction. Here, you see, HCl. Here you see POCl3 is being produced. Now, this POCl3 will further hydrolyze. This POCl3 will further react with water. It will produce what? Now, this is important. It will produce H3PO4. This is the two-step reaction that you need to remember over here. In the previous case, it was one-step reaction. But in this case, it is two-step. Two-step reaction. Is it clear to you? Kindly write this. One more thing, very most important thing. See, when we heat PCl5, okay, it decomposes on stronger heating. On strong heating, PCl5 decomposes into PCl3 along with Cl2 gas is liberated. This is most important. On strong heating. When you heat it means you heat it at a normal temperature, it will sublime. Now, what is sublime? When you directly convert solid into gaseous form, it is sublimation reaction. But on strong heating, what will happen? It will convert into PCl3. Phosphorus penta chloride will convert into phosphorus trichloride. Is it clear? Is it clear? Now, other than the students, one more thing that is generally asked is about the structure. If you draw the structure of this, basically PCl5, you shall be seeing that basically these two are the axial bond length and these are the equatorial bonds. So, this is the structure for PCl5. The hybridization over here is sp3d. These two are your axial ones and the other 3 are the equatorial ones, and the axial ones have more bond length in comparison to the equatorial ones. If you need to remember the bond length value for the axial ones, it is near about 240 picometer, and if you need to remember for the equatorial one, it is near about 202 picometer. Okay, so this is basically the structure that they can ask you with regard to the PCl5. Is it clear to you, students? So this ends our phosphorus over here and ends our nitrogen family. Now comes our next topic, that is group number 16, the oxygen family. As again I have told you, the oxo acids of phosphorus and the oxides of nitrogen, we shall study them all together. Okay, because I have had to take the NCERT image, so I will be taking in the next lecture. Don't worry about it. Now talking about oxygen family, what are the elements present in oxygen family? Basically it is group 16. Why it is referred to as a group 16? Because its electronic configuration is NS2NP4. What was the electronic configuration of nitrogen family? It was NS2NP3. What is the electronic configuration for oxygen family? It is NS2NP4. Now what are the elements present in oxygen family? It is referred as oxygen family. That means the very first member over here is oxygen itself. The very first member over here is oxygen itself. The next member over here is sulfur. The next member in the oxygen family is sulfur. Now the next member over here is selenium. Selenium. Is it clear to you? Now the next member is tellurium. Tellurium. Next is polonium. Polonium. And there is one more member that is basically that you don't have to study. You can correct if there is any spelling mistake over here. One more is also there. That is radioactive in nature and it has a very short lifespan. So we don't study about it. So basically these are the members of oxygen family. First of all, what will be their atomic numbers? We know the atomic number for oxygen is 8. Now you remember magic number I told you, it is 2, 8, 8, 18, 18, 32, 32. And you know that from here when we are starting, we will be using this formula. Now we will be doing what? If its atomic number is 8, you will add 8 over here. You will get the atomic number for sulfur, that is 16. Now in the very next step, you will be adding 18. Now when you will add 18 in this 16, you will be obtaining 34. That is the atomic number for selenium. Now after that, what will happen? You will be now adding 18 again over here. You will be getting 52. This is the atomic number for whom? This is for tellurium. Now next come for polonium. Now you will be adding what? You will be adding 32. You will be obtaining what? It is 84. Is it clear to you? Polonium is 84. So these are the atomic number. Which ones are the atomic number? 8, 16, 34, 52, 84 are the atomic number. Other than this, students, again, they both are non-metal. These both are metalloids. These both are metalloids. And if I talk about, again, it is radioactive in nature and it is a metal. Is it clear to you, students? Radioactive. Also, one more thing. They can ask you if it is radioactive, what is the T half value? The half-life time is 13.8 days. This is certainly asked with respect to polonium. Is it clear to you? Is it clear to you? So, one more thing. Oxygen family are also known as chalcogens. One more thing. Oxygen family are also known as chalcogens. Now, what are chalcogens? Chalcogens are ore-forming family. So, these are the very basic things that you need to remember with respect to the oxygen family. Now, students, kindly write it. We shall move to the physical properties with respect to the oxygen family. Now, when I move on to the physical properties, first of all, before going to that, we have the occurrence part that you have to directly read from the NCERT. So, this is again your homework. See, one thing I've given you as a homework of the uses that you have to study. Another one is this one. Great. Now comes the electronic configuration that we have already done. Now, the very first physical property is atomic radius. See, this is very simple. First of all, write the elements: oxygen, sulfur, selenium, tellurium, polonium. See, as you go down the group, what will happen? Number of shells will increase. If number of shells increases, what will happen? Atomic radius increases. Why atomic radius increases? Because the distance of the center of nucleus to the outermost shell is also increasing. Great. So this is very simple. Atomic radius increases down the group. Now comes the next physical property, that is the ionization energy. Now if I talk about the ionization energy, if you remember in the nitrogen family also I told you, here ionization energy will decrease. Now what is ionization energy? Taking one electron from the outermost shell. See, when we are talking about the initial elements, oxygen, sulfur, selenium, tellurium, polonium, if I talk about oxygen and all, they have very less amount of shells in comparison to the downwards one. So what will happen? The outermost electron is quite close to the nucleus in comparison to the other ones. So the electron that we need to take out from the outermost shell, there will be more amount of energy required in oxygen in comparison to the polonium, because in case of polonium the shell is at a far distance, so you can easily remove the electron by supplying some amount of energy. So ionization energy decreases down the group. Ionization energy decreases down the group. Now one more important thing that you need to remember, they ask you the comparison of group 15 and group 16, which will have more ionization energy for the removal of first electron. So what you will say, group 15 will have more. Why? Because what is the configuration for this? NS2 NP3. What is the configuration for this? NS2 NP4. If you have to show in the p orbital, this is NP3, 1, 2, 3 electrons. Over here, it is NP4. It is 1, 2, 3 and 4 electrons. So this is a half-filled electronic configuration. Half-filled electronic configuration and the fully filled electronic configuration are more stable. So if you have to remove electron from here, you will require more energy, because it will become unstable after that. But over here, you can easily remove this one electron. So in group number 15, the ionization energy value is more in comparison to the group 16, because it is more stable, because it is half-filled electronic configuration. And you have to give it more energy. Is it clear, students? So yes, my dear students, your homework for today is read your NCERT till where we have studied. Also solve your practice sheet that is being provided to you. And you can ask your doubts from the practice sheet in the comment section, and we will be discussing all the homework questions and the doubt questions all together. So before ending, students, I would say you one thing. Do remember this. When things go wrong, as they sometimes will. There is never a smooth path, right? So when things go wrong, as they sometimes will, when the road you are trudging seems all uphill and you want to smile, but you have to sigh. When care is pressing you down a bit, rest if you must, but don't you quit. So, students, never quit. Never say that I cannot do anything in my life, because you can do anything if you want to. If you have belief in yourself, if you trust yourself, then you can do anything. But if you think that you cannot, you have just kept it over here in your mind, I cannot do that, this not, cannot, must not, should not, just delete this word from your dictionary and bring these positive words. I can do, I will be capable of doing this if I want to do. So bring this positive words in your life and see, automatically you will find a huge change in your life. So kindly solve the practice sheet, and yes, in the next lecture we shall be completing the group 16 completely, and we'll be moving further to the group 17 and 18 as well. So meet you in the next lecture. Till then, keep smiling, keep learning. Thank you so much and have a good day.